In the following video, I will try to speak English to read some articles from the website. The first reason is I want to learn English. The second reason is I want to learn the knowledge behind the articles. So let's start it. Please note, I am not an English native speaker, so my English is very poor. This video is just for myself to promote my English. Okay. The first article is Estimators Revisited Deep Neural Networks. In this article, we will learn how to train an increasingly complex dataset by converting a linear 太烂了。In this article, we will learn how to train an increasingly complex dataset by converting a linear model to a deep neural networks. As the number of feature columns in a linear model grows, it can be increasingly difficult to achieve high accuracies in your training as the interaction between different columns gets more complex. This is a knowing problem, and one particularly effective solution for data scientists is to use deep neural networks. So, the first question is why go deep? Deep neural networks are able to adapt to more complex datasets and better generalize to previously unseen data, primarily due to its multiple layers. Hence, that's why they are called deep. These layers allow them to fit more complex datasets than linear models can. However, the trade-off is that the model will tend to take longer to train, be larger in size, and have less interpretability. So why would anyone want to use it? Because it can lead to higher final accuracies. One of the tricky things about deep learning is getting all the parameters just right. Depending on your dataset, these configurations can seem virtually limitless. However, TensorFlow's built-in deep classifier and regression classes supplies a reasonable set of default values that you can get started with right away, allowing you to get going quickly and easily from linear to deep. Let's see an example of how to update our iris example from a linear model to a deep neural network, often abbreviated as DNN. I'm not going to show off a 2000 column model that a DNN can leverage, so I'm just going to use the 4 that we've been using throughout this series. The mechanics are the same either way. The main change comes from replacing our linear classifier class with DNN classifier. This will create a deep neural network for us. Other changes. virtually everything else remains the same. There is one additional parameter that is required for the deep neural network that we did not include previously, since deep neural networks have multiple layers, and each layer has potentially a different number of nodes. We will add a hidden units argument. Model director. The hidden units argument allows you to supply an array with the number of nodes for each layer. This allows you to create a neural network simply by considering its size and shape, rather than wiring up the whole thing from scratch by hand. Adding or removing layers is as simple as just adding or removing an element in the array. More options. Of course, with any pre-constructed system, what you gain in convenience, you often lose in customizability. DNA classifier tries to get around this by including a number of additional parameters that you can optionally use. When left out, some reasonable defaults are utilized. For example, the optimizer, activation function, and the dropout ratios are all available to customize along with many others. And that's all. What else do you have to do in order to convert our model from linear to deep? Nothing. That's the beauty of using the estimator's framework. One common way to organize your data, training, evaluation, and model exporting, while still giving you the flexibility to experiment with different models and parameters. Going deep the easy way. Sometimes deep neural networks can outperform linear models. In these situations, TensorFlow makes it easy to switch from a linear model to a deep one with very few code changes by leveraging the estimator's framework to replace just one function call. This means more time to work on your data, model, and parameters rather than wiring up the training loop. For easy neural networks, use TensorFlow estimators. Thank you.